Sure. Well, welcome everybody to the Astro Cafe on Monday, the 21st of November. We recently had the launch of Artemis, so we're going to do a few talks about Artemis, and then there's a few announcements to make. Is there anybody else here who'd like to go on the schedule? Is there anything else that anybody wants to present or any announcements? Okay, well, I'll work through what we have, and certainly if anything comes up, let me know. I wanted to start. We have a couple of presentations and information about Artemis, which is the new program now, the new NASA program that's scheduled to go to the moon and then perhaps beyond that. I wanted to just go back a little bit and talk about the moon. There's some information about it, some theories about it we'll be testing with further exploration, and just some issues that may arise that I just wanted to bring to your attention so that over the next few years you're aware of this kind of stuff potentially coming up or creating issues. You see my screen now, guys? Just give me a thumbs up from somebody? Yeah, perfect. Thanks, Dave. Okay, so if anybody's been hibernating, Artemis launched November the 15th at 10:47 Pacific time. Artemis, this Artemis was the first test of concept of the space launch system, and I think they have the Orion capsule on it. They'll be running testing over I think it's about a 25-day mission. The information I'm going to present comes mostly from a text on the solar system by Michael Seeds. It's a 2018 book, but also from some of the information comes from UVic, a course taught there called the Solar System, and I confirmed some of the information through the NASA web. Just an overview of the moon, and you guys know this stuff probably better than I do. So if there's anything that you want to correct, please feel free. When you look at the moon, there's basically dark areas, the Maria, the seas, and the highlands, or the Terra. Quick facts: the radius of the moon is about 1/4 of that of Earth. Density of the moon is about 60% of that of Earth. The mass of the moon is about 1/80th of Earth, which leads to gravity being about 1/6 that of Earth. Meaning the escape velocity for anybody trying to get off the moon is about 1/5 of Earth. And that obviously the escape velocity is going to be something that has to be taken into account with whatever lunar landing vehicle they eventually decide on. And as I understand, that's still being decided in terms of how it's going to be used and what the lander's going to want. Surface conditions on the moon, it varies between the minus 173 and 130 degrees centigrade. The atmosphere of the moon is about 1/10 to the 15th that of Earth, which is a scientific way of saying there's no atmosphere. Factors that promote or have led to the lack of atmosphere is firstly gravity being 1/6 that of Earth, and the lack of a magnetic field. And when there's no magnetic field, the solar wind will destroy whatever atmosphere is there. The advantage for us, though, is that with no atmosphere, you get very sharp shadows at the terminator. So it makes good observation and good photography. This is a very basic photograph that I took of the moon, but you can see, of course, as you all have who've done photographs, that there's a very sharp images and shadowing of the craters right at the terminator, the area between the light and dark, or where the sun is impacting and the shadow on the moon. Usually ideas about moon origins in the solar system are either catastrophic slow formation, which is accretion similar to the planets, or gravitational capture. The overwhelmingly favored hypothesis for the moon at this point is a giant impact. And in the giant impact hypothesis, the moon has been formed from a ring of debris that was ejected into space when a large planetoid struck the Earth after the planet had differentiated. So this would account for the orbital inclination of the moon that we'll come to in a minute, the low density of the moon, and also the lack of volatiles found at this point on the moon. The interior of the moon, basically planets are made up of crust, mantle, and core. The core on the moon is thought to be quite small. The moon originated as basically a magma ocean about 4.5 billion years ago. Because of the tidal lock of the moon, the far side of the moon cooled earlier, and with the early cooling, it became thicker. Because it became thicker, there was less breakthrough of magma, so there's fewer areas of mare on the moon. There is no magnetic field at this point, or no magnetic field that can be detected, which is, of course, what led partially to the lack of atmosphere. But there is evidence in some of the rocks that were brought back that there was a magnetic field at one point. So that's going to be something that I'm sure they'll be looking at with the moon rocks. As I said before, the moon is in tidal lock with the Earth, so the moon orbits every rotation, every orbit. The moon rotates every orbit of the Earth, so it's a one-to-one lock. The orbit is a little bit elliptical. It's about 45,000 kilometers off the major axis compared to the minor axis. The moon orbits aligned at 5 degrees to the ecliptic, and again, that's one of the thoughts, or one of the reasons I think made some kind of impact that seeded the moon, or seeded the debris that became the moon. The moon has both dark and light areas, and it's currently thought that the dark and light areas are because things have quite different origins. The terra, or the light areas, are primarily anorthosite, which is a type of magma which results from cooling on the surface. The terra are older, are about 4.5 billion years old. The maria, or the lakes or the seas on the moon, are formed, or thought to be formed, from heavier magma, which originated deep in the moon and broke through the surface. They're made up of basalt. So essentially, igneous rocks, both the light and the dark areas. The current idea is that moon formed. There was cratering, a lot of meteorite strikes 4 billion years ago in a major bombardment, and then some of the bombardment actually cracked some of the surface of the moon, and the magma flowed up, made lava lakes. They cooled, but because there was no bombardment, there's less cratering of the lakes. There aren't lakes, there aren't mare on the far side, again because the crust there was thicker, and there was less or no magma breakthrough in the later formation. So the rocks that came back from the moon are really quite distinctly different, and you can see why they make light and dark areas on the moon. From the mare, there's the basalt and the anorthosite from the terra, or the highlands. Leaving us with the moon that we know now, consisting of the named mare and the highlands with the cratering. One of the interesting things that I think we're going to be paying more attention to as there's more exploration on the moon is actually the lunar dust. The lunar dust is made up of tiny particles, the regoliths. The regoliths occur because of micrometeorite strikes on the rock, which breaks off little bits over the billions of years. In some areas that the dust is thicker than in other areas, but because they're exposed directly to the solar wind, they're charged, which means they're very static and they cling to everything. So the rocks are also very, very, or the regoliths are also very sharp because there's no weathering on the moon once they've been knocked off. That's going to be a concern, I think. It's going to adhere to spoot suits, and the sharp little particles are going to create some issues with the gaskets and seals and solar panels. The other thing, that you need to be concerned about if this is an environment that guys are living in or that the individuals are living in, is just if the dust is breathed in, it can potentially cause some harm to the lungs. So we'll see what comes of that. This is just a magnified view of one of the regoliths, just showing how irregular it is. The 6 lunar missions that landed chose very specific areas. The 11 and 12, the first two landings landed in the Mare. They were thought to be a little bit lacking in cratering, so a little bit easier to land. After they developed some experience, the last 4 missions landed in areas of highlands or terra. So we have rocks from both areas, and probably there were some of the missions that were able to travel far enough that they were able to get rocks from both the Mare and the Terra. So we're now moving on to the next mission called Artemis. Chris, do you want to take over the screen?
Okay. So. Okay, everybody see that?
Yes. Yep. Yeah, that's good, Chris.
So yes, I suspect that for a lot of us, even me to a certain extent, Artemis has kind of snuck up on us. So I'm going to talk a little bit about the current mission, Artemis I, and then I will go back and talk about the kind of tangled history of Artemis, and also what's coming up, which will be of great interest to us, I think. So anyway, this is one of the nicer photos of Artemis I on the pad, and the target is in the background. So what's going on during this mission? Artemis lifted off about 6 days ago. It just a couple of hours after, maybe an hour after our council meeting wound up last Tuesday evening. It lifted off from pad 39B at the Kennedy Space Center, and so it has just it's quite a complicated trajectory, but the idea is that this is kind of their robotic or unmanned or uncrewed or whatever you want to call it test of the full Artemis spacecraft before they put humans on board, which will be on the next Artemis. And they're doing some things here that they don't plan to do with the next mission, because they want to give it a good shakedown. So in the past week, it's flown out to the vicinity of the moon, and this morning, I think at about 4 or 5 in the morning Pacific time, we got to number 9 on this chart, the outbound powered flyby. Actually, the Artemis fired its engines, and it has kind of put it into a route towards a second burn, which you see at point 10, which will take it in a very elongated orbit around the moon. It will do one orbit, and it will actually go out a couple of thousand miles from the moon, and during that time, it will have gone out farther away from Earth than any of the Apollos did. Interestingly enough, the Apollo that went the furthest from the Earth during its flight was Apollo 13, which failed to land on the moon, but it did go far away. It actually didn't even go into lunar orbit, but it holds the distance record, and so the folks at NASA decided they wanted to test the Artemis at an even greater distance. So they've put it into this, or they want to put it into this retrograde orbit. The burn this morning, I guess, you know, Peter could have got up and watched it without too much inconvenience. I slept through it, but watched the replay later on. The burn on Friday to put it into this retrograde orbit, I think is it's about 4 in the afternoon out, on Friday out here. And so to do this orbit, it'll be in that orbit for about a week or so, and then it's going to make a leisurely progress back to Earth, and if all goes according to plan, it will splash down in the Pacific on December 11th. And interestingly, by then we will be into the 50th anniversary of Apollo 17, which was the last Apollo flight to the moon. It lifted off in the early hours of December 7th in 1972. I think that was Eastern time. It actually might have been December 6th over here still. So it's a shakedown of the whole spacecraft, and I'll get to the design of the spacecraft in a few slides. Early in the mission, by the way, it dropped off a few very tiny satellites, you know, not much bigger than this. I think 10 of them, and not all of them are working, but they warned that not all of them would work. So I imagine we will hear about that as time goes on. And you can also see in this chart, the dotted line, the stage that actually put it en route to the moon is been put into a solar orbit now. Like some of the third stages from Apollo, although some of them were crashed into the moon once they had seismometers on the moon. So here are a few pictures, actually from most of them from these were from the first day. A view from the pad of the launch. So even though the SLS Space Launch System rocket that launched Artemis is smaller than the Saturn V, it's actually more powerful. I just heard a couple of hours ago from a friend of mine who actually saw the launch, and he's seen a lot of launches, and he was quite impressed by the show that thing put on, because of course it was after midnight when he saw it, so it lit up the whole sky. And then next to it at the right, you can see the Earth sort of falling back into the distance a couple of hours after translunar injection, the translunar injection burn. And then under that, at the right, you can see a shot of the Earth. That was about a day out, and I think it was, I forget how, it was about 40,000 miles away, if my memory serves me right. Now, Artemis has 4 solar panels that stick out from the service module, and they have little cameras on it. So this is actually one of the cameras on the at the end of the solar panel. So it's showing you the service module, and you can see the engine up at the top that it uses to maneuver. Like, for example, it was used for the burn this morning and be used for the burn on Friday. And then at the bottom left, you can see the inside of the spacecraft. Now, it looks like somebody's sitting there, but that's actually a dummy, and there's 3 dummies in there. They're testing the spacesuits, and they also, at least one of the dummies has a simulated human tissue, because they want to see what the effects of the flight, mainly the radiation that you get when you go to the moon, because you're going outside the Van Allen belts, have on the human body. And then there's all sorts of other equipment in there, and there's souvenirs and things like that. But you can see some of the windows. There's 4 windows, and when it's flying people, it will be able to carry 4 people. So these photos were taken this morning. So as we know, we're getting pretty close to a new moon here. So most of the moon that's lit up is the far side, and so these were taken as the one at the upper right was taken as it was approaching the moon, and then we had an Earth set, which you see in the bottom right. Just a few moments after that picture was taken, the Earth started to disappear behind the moon, and then the signal was lost for about half an hour. And during that time, the engine was fired to get it on its way to the point where they want to have this burn on Friday. And about a half an hour after it disappeared behind the moon, it came around from behind the moon, and the first thing it sent was images of the Earth. But there's a very nice shot here at the left of the moon from a perspective that we don't get to see it unless we can climb onto a spacecraft like Apollo or Artemis. So that's and you know, I expect to see more photos as time goes on. Now, it shortly after that burn today, it got as close as 81 miles from the surface of the moon, but at that point, it was over that part of the moon was in darkness. So there's been a lot of talk about, I was watching the press conference, and there's all sorts of questions. Well, what time did it fly over Tranquility Base, the Apollo 11 landing site, and all that? It will be flying over when it comes back later on in the mission, it will make another close pass to the moon, but the near side will be more illuminated then, so we might see pictures of that. But you know, amidst all the hype about Artemis, it's kind of forgotten that since Apollo went to the moon, there's been a number of robotic spacecraft that went to the moon. Probably most famously Clementine in the 90s, and then the Lunar Reconnaissance Orbiter, which I think is still orbiting, and it has actually taken some amazing pictures of the moon, including photos of all, you know, close-up photos of the all the Apollo landing sites. You can see the trails where the footprints went. And you know, I'm sorry somebody hasn't taken it upon themselves to do a book of some of the LRO photos, because they had an exhibit of some of those photos at the Smithsonian when I was there a few years ago, and some of the pictures were just astonishing. Yeah, I particularly remember some around Tycho, real close-ups of the area in Tycho and around Tycho. So anyway, but I'm gonna leave further discussion of the moon to people who know more about it than I do. So we will be getting some more pictures, and we still have a lot of mission to go. Now I want to get into the background to Artemis and tell you, because it has quite a long history, and there's more than a little politics in the story of Artemis. So let's just review here. So 50 years ago, Apollo was winding up, and you had all these people who worked on Apollo, and when Apollo ended, even with things like, you know, they had the Skylab with Apollo equipment and Apollo Soyuz, there are massive layoffs in the US aerospace industry. And that was a big reason why President Nixon decided to go ahead with the shuttle in 1972. And as we know, that flew for 30 years until 2011, after, you know, being built up over the 70s to flight status. Now that employed a lot of people, and so when the shuttle ended, they weren't very happy about the prospect of losing their jobs, and I'm going to get back to that point in a couple of minutes. We've also had the International Space Station, which has been going for you know, more than 20 years now, and so that's the focus of the U.S. human space program right now. But what about going back to the moon? You know, the Apollo was allowed to end, and a big reason is because the politicians at the time, President Nixon at the head of them, saw that, you know, the American people thought, well, we've gone to the moon now, let's worry about problems on Earth, you know, and I won't go into the long list. So, and the hope of that by going to just the space shuttle was that they were going to get lots of exciting space flight, but not with the great expense of Apollo. And even though NASA's spending was cut back, the space shuttle wound up costing a lot more than was hoped. But 20 years after Apollo 11, their talk came up, well, let's go back to the moon. By then, the scientists have been able to process some of the results from Apollo. So on the 20th anniversary of Apollo 11, the first President Bush got together with the crew of Apollo 11 and announced that they were going to have the Space Exploration Initiative, which was to return to the moon and then eventually on to Mars. The Space Exploration Initiative was killed within a year, practically. First of all, there wasn't much interest in Congress in spending that sort of money. And even there was even some resistance in NASA to this, and it's a very, very complicated story, but it didn't last very long. So that kind of went by the wayside. And over the years, there's been a lot of argument. Well, should we go to the moon again, or should we just go straight to Mars? And you had people like Robert Zubrin, saying, well, we got to go to Mars, like the moon is just a big distraction. But anyway, that's gone on, and I won't get into that today, but it's been in the background. So in 2003, in January 2000, or actually February 1st, the shuttle Columbia came back to Earth and was destroyed during its reentry, and that was the second loss of a shuttle and its crew. And the younger President Bush, who was in office by then, and the powers that be decided that it was time to wind up the shuttle program. And so a year later, in January 2004, President Bush went to NASA and announced what he called his vision for space exploration in 2004, which I'm going to talk about in the next slide. And I just threw in here the Commercial Crew Program, which of course is Elon Musk, but maybe I'll mention that a little later. So very shortly after the younger Bush's announcement, the Constellation program came out of that, and the idea of that was to use rockets or sort of hardware based on shuttle hardware to build rockets, which were going to be called Ares rockets. And you'll notice that the one at the very left looks a lot like the rocket that was launched the other day. There's going to be a whole bunch of different rockets that to launch freight into space and also cruise into space. And the plan was to go to the moon and then eventually go on to Mars. And during that time, they decided to start creating the spacecraft for the crew, sort of the command module type spacecraft, which was called Orion. And you'll notice that's still the name. So part of Artemis, or a big part of Artemis, actually dates back to this Constellation program. So part of the Bush vision was to wind up the shuttle program and then eventually wind up the space station. Well, the shuttle program was wound up, but and the hope was that would free up a lot of money to put into Constellation. Well, not that much money was freed up, shall we say. So Constellation kind of went along, kind of slowly. And then in 2009, the second Bush was succeeded by President Obama, who had a big review of the space program, and Obama came up, and his administration came up with some different ideas. They ended the Constellation program, but work continued on with Orion. But the Obama administration, instead of going to the moon, was promoting sending Orion to an asteroid. And I actually thought that was a pretty neat idea. But my viewpoint was very much in the minority. A lot of people thought, well, we should go to the moon and go to Mars and forget about the asteroids, at least in terms of sending humans there. And so it kind of struggled along. But there was a big confrontation during this time between the Obama administration and Congress. Obama wanted to promote private space flight, and some of that had started a little bit under the second Bush, but Obama really started to push this. But the Congress didn't like that idea so much. They did provide some funding for the Commercial Crew Program, which has led to these Dragon spacecraft and all the great things, at least at SpaceX, that Elon Musk is doing. But the Congress insisted on that NASA should continue to build large rockets similar to what was in the Constellation program. And so out of that came the Space Launch System. Obama realized that he could not get what he wanted with Commercial Crew if they didn't build the SLS. So why are they doing that? Well, it's because there's all these people who had jobs around the states building shuttle gear, and there was a call for they didn't want to lose their jobs, and these Congress people didn't want to be seen as the ones taking away their jobs, and we'll get to that. I just want to mention that during this time there were a couple of test flights. In 2009, the one Ares rocket that ever flew made its flight, and it was basically just one of these solid rocket motors from the shuttle program, and it just went up and came down, and it didn't actually go up that high before it kind of split in two. And then in 2014, there was a flight of the Orion spacecraft without the service module. So this flight that's going on now is actually the second flight of the Orion spacecraft, and it went on top of a Delta IV, which is at least until last week the largest rocket in the U.S. fleet available anyway, and it made a couple of orbits and made a successful flight. And so anyway, the Space Launch System was born out of the ashes of Ares and the Constellation program. And of course, the irony of all this is that you might recall some of the political struggles of the Obama years, which have continued on, where you had all these Republicans who were regularly condemning Obama for being a socialist and a communist and everything else, a big government person. And here in the world of space, Obama was promoting private space, and the Space Launch System was the big government system was being promoted by Republicans, because most NASA facilities and states like Texas and Florida are represented by Republicans. So, it's one of the things that we love about politics. It reminds me a little bit, Tip O'Neill, the Speaker of the U.S. House, used to say all politics is local, and this is a good example of this. So anyway, these are all variants on what could come out of the Space Launch System. Whether we will see many of these variants is another matter. The rocket that was the SLS rocket that was launched last week is of course similar to the one at the left here, the Block 1 Crew. So you can see here, it's basically got a giant shuttle external tank, except at the bottom, it has 4 shuttle engines. Whereas the shuttle itself had 3 engines, which were on the orbiter and had the fuel piped in from the external tank. Then at the side, it has these solid rocket motors, which are similar to the 2 solid motors you had on the shuttle. These ones are longer. The shuttle ones had about 4 sections, and these have 5 sections. So when you put these together, you have even for this smaller one at the left, you have a more powerful rocket than the Saturn V. You also have the most expensive rocket. You know, it's estimated that this mission is costing in the neighborhood of $4 billion. Each Artemis mission, which is way more than previous missions, because it's using the large aerospace companies with their big cost plus contracts, and all these people who have worked in the shuttle for a long time and are used to the great big paychecks. SpaceX doesn't cost as much, and maybe another time we can get into the reasons for that. So the SLS has been widely criticized. I think a number of us saw Bob McDonald give a great talk up at the Center of the Universe earlier this year with his take on the SLS. He called it the Frankenstein rocket. You can see the slide there. Some people call it the Senate launch system. Just the other illustration in this slide shows where the engines on the booster that flew last week came from. And of course, you only have one flight on this rocket. It's now that rocket is in the bottom of the ocean somewhere. But you can see that those engines, actually, each of those engines flew a number of times in shuttle missions, and then were brought back to Earth and refurbished and all that in a number of missions, including Hubble repair missions. So, because of the great expense of the SLS, they don't fly every now and then, because NASA doesn't have the same type of budgets it had back in the Apollo days. I just to drive the point home a little bit, I made up this slide, which shows the rocket and compare it to the shuttle, and you can see some of the similarities where they come from. So, so this is the Orion spacecraft as it is presently constituted. Up here is the crew module. It can, it's bigger than Apollo. It's certainly a similar shape to Apollo, but it's actually bigger. It carries a crew of 4, and I think in a bit more comfort than Apollo. And then the service module is actually built by the European Space Agency. So this current flight is the first flight with the service module attached. And at the left, you can see the configuration just shortly after launch. And that upper stage that you see there was used for the burn to get it from Earth orbit into the onto the route to the moon, and then that upper stage was let go, and now it's gone into a solar orbit. So Artemis, Artemis, as we know it today, that was actually kind of the term actually was reached by the Trump administration. And an interesting thing about the Trump administration is that even though you know, we all know how controversial Trump is, and probably agree with most of that controversy, his space policies for a one-term president were very strong, and actually were not that controversial. So by the time Trump took office, there was a move to, let's not have this asteroid thing. Let's get the SLS going to the moon. So he named it Artemis after the sister to Apollo. And it actually has two phases. And this is a slide that was produced in 2017 when it was started. Basically, phase one is to get back to the moon and also do some exploration to the moon. Some of these shots that you see here are not on the agenda anymore, but there is a plan to launch a thing called the Lunar Gateway, which I'm going to talk about very shortly. Phase two of Artemis, which I haven't put here, but there was a similar slide. Phase two of Artemis is to go on to Mars, maybe in about 20 years or so. Whether that happens, of course, remains to be seen. We've had one change of administration already, and we might have another one before too long, given that Joe Biden turned 80 yesterday. And so we'll see. But officially, Artemis still has the target of going to Mars in the fullness of time. So, so I've talked a little bit about Artemis I, and then there's Artemis II. So this mission is actually will be shorter and simpler than Artemis I, because there will be 4 astronauts on board. So you can see it's kind of like a mission, kind of like Apollo 8 or Apollo 13. It's not going into lunar orbit. It's just going to loop around the moon and come back, which is what Apollo 13 wound up doing, even though that wasn't the plan. So there will be 4 astronauts on board, and one of them will be from Canada, and it will be one of these 4 people here. These are the 4 Canadian astronauts. NASA signed an agreement with CSA, and it you know, part of that deal was that one of the astronauts on this mission will be Canadian. Now, so from left, so we my God, I've just my memory is going on me. So at the right, we have David St. Jacques, who's been in the program for I think since 2009, and he made the last flight. He did a stint on the ISS, so he probably won't be going. But the other fellow who's at the left, who's also chosen in 2009, I think is going to be in probably a few weeks after Artemis I returns, will be announced as a Canadian astronaut, and that's Jeremy Hansen, who is you know, quite experienced, has done a lot of work down in Houston since he was selected as a Capcom and things like that. He's a jet pilot. He's kind of Chris Hadfield without the mustache and the singing. And then the other 2 people in the middle, Jen Slidey and Joshua Kutrick, were selected, I think, around 2014 or 2015. So they're more junior. So I think a lot of people are pulling for Jeremy to get that flight. And I noticed that he was down at the Cape last week taking in that launch. and with any luck, he's going to be on the next one. So Artemis II, when will it fly? There's, I think the current guesstimate is May of 2024. So we'll see if that comes off. So after Artemis II, we have Artemis III, which is supposed to include a landing on the moon. That's supposed to take place in 2025. I'd be very surprised if it took place that soon. So with Orion, you have the command and service module, but what about the lunar part of it? Well, a year or two ago, NASA awarded the contract to SpaceX to use their Starship, which is being developed, and you can see at the bottom right. This is what it's supposed to look like when the Starship undocks from Orion and then lands on the moon. Looks almost like a sci-fi flick. And right now, SpaceX is busy flying or doing tests on Starship. And if it works, and a lot of people think it will, but it hasn't been proven yet, it will revolutionize spaceflight. It will be a lot cheaper than spaceflight has been up to now, even including the Dragons and the Falcon rocket that Musk has already built. And in fact, it could be that Musk starts sending starships off to the moon and even farther beyond without NASA being involved at all. Some people think that a starship may get to the moon on its own before the Artemis gets to the moon. We will see. It's going to make this decade kind of fun for us space geeks. So Artemis III will hopefully not be the last flight, but as part of the Artemis program, Canada has signed on to the program, and it is going to build the Canadarm3 to go on the Lunar Gateway. Now, what's the Lunar Gateway? It is supposed to be a space station established in lunar orbit, and you can see there's a number of agencies involved in it. Basically, a lot of people who are involved in the ISS, and so what the idea is that in the future you can in future Artemis flights, you can hop on board the Orion, go to lunar orbit, and then go into the Gateway, and then the landing spacecraft, which after the first two may not necessarily be starships, but we'll see, will then go to the surface, spend time on the surface, doing probably more and more elaborate things as time goes on, and then come back to the Gateway. Now, the Gateway is a controversial part of the Artemis program because a lot of people are saying, do we really need it? So time will tell how that all turns out, because but the work is already starting, and we are part of it. So that is that's basically the story of Artemis. So I hope you've learned a thing or two, and if there's time, I'll be happy to answer any questions.
That's fantastic, Chris. Thank you very much. Are there any questions right now? Anybody, anything occurring? Chris, while we're waiting for that, perhaps you could tell me with the landing system that they're proposing for Artemis III. I'm assuming Gateway is not going to be built. How do they propose to transfer from the Orion spacecraft to the?
Well,
Lunar?
just directly,
Hmm.
just like, like from an Apollo command module to the lunar module.
But is it being sent up with them and integrated?
No,
with the sat-
I assume it would go up separately from the SLS, and but yeah, I mean, it's interesting, this sort of tower thing landing on the moon. But of course, I think the reason that's believed to work is, we have such a massive amount of computing power at our disposal that you can land something like that. There's no way you could have landed anything like that back in the time of Apollo, because they had those little rinky-dink computers, right? That back then, that had a fraction of our these things, and weighed 40 pounds if you're lucky.
Interesting. Reg, do you have a question?
Yes, thanks for the talk, guys. It was great. My question is going back to the solid booster rockets there. I was just wondering if they were still being made by Martin Thiokol and if they still have O-rings in their design. Do you know that?
Well, Martin Thiokol has been gobbled up by I forget who it is. It's one of the big ones, Boeing or something like that. But it's basically the same crew out in Utah, and they have O-rings. So because they ship those things in segments. The shuttle the shuttle boosters had 4 segments in it. These have 5 segments in it, so you actually have an extra O-ring in it. But there's design features built into it so that they're more secure than the ones you had at the time of the Challenger explosion.
Yeah, I just watched yesterday the Challenger documentary on Netflix. It's a 4-part series. It's quite interesting. And they went to great length explaining how they had improved the O-rings from the first get-go. So I'm not quite so worried, but thanks for that, Chris.
That's right.
Interesting. Randy, do you have a question?
Yeah, I saw that the rockets, the actual engines in the SLS are recycled from the shuttle.
Yes, that slide I showed you from with Bob McDonald in it showed had a little window of it with the history of those engines. Some of them had flown 12 times before, but this is the last flight. So the interesting thing is that they have 16 shuttle engines that they can use for Artemis. So they've just used 4 of them. So they have enough for 3 more SLS flights. So now they're building some new ones for future SLS flights. But it'll be interesting to see how far the program goes, because the huge expense, and it also depends on how our friend Elon Musk does. If he sticks his nose into stuff that he shouldn't be, like Twitter. I'm not sure how long it'll last, but anyway, we'll see.
Interesting.
Cool.
David, do you have a question?
Yeah, I actually had 2 questions. One for you, Jeff. Is the core of the moon completely solid now, and that's why there's no magnetic field, or is it just small, the liquid part?
It's an excellent question. They suspect that it's solid at this point, but the size of it, because of the low density of the moon, the size of it isn't one that, even if it was liquid, could have generated through the dynamo effect actually a magnetic field. So one of the things they're looking at is why there's signature of magnetic field in the rock, but the suggestion of the density of the moon and the size isn't one that would normally give rise to a magnetic field. So it's an interesting area, and there's going to be more work on that.
That's really cool. And then just on the pictures of the part that goes around the moon there, Chris, it looked like the parts are riveted together. Is that for thermal cracking? And just why wouldn't they weld those parts, making it lighter and stronger?
Oh, I don't think they're riveted together. I meant they are put together very solidly. A lot of those pictures you're looking at are of the service module though, but they have to. The service module has to survive the launch. You know, it's thrown away before reentry. But I'm sure everything is put together very solidly.
It just looked like there were rivets all over the place.
Yeah, there were
Anyway,
I guess almost I think they almost looked like little fins there, but I think they were to just kind of help cool things because they cast shadows in that ring. I think that's what you're referring to, but
it's okay. Thanks.
Are there any other questions that anybody wants to ask, either me or Chris, before we move on?
I have a comment.
Please go forward, Margie.
Okay. Last spring, there was an opportunity with NASA for the Artemis program to have your name go to the moon on this launch, if you wanted to do so. And so I filled out the form. So my name, my sister's name, and a friend's name are all on perhaps a USB. I don't know what it is, but with millions probably of other people. And so my name is at the moment flying either to the moon or very close to the moon. And I have a certificate that says.
Yay!
Yay. Yeah, I've got one too. Yeah. So if you want to get in on something like that, it's too late for this one, but I'm sure they'll have it for future missions.
Yeah.
Excellent.
That's how they pay for it.
The cost just goes up each time. That's great. Randy, did you have something that you wanted to
I do indeed. So, there we go. You're supposed to go into presentation mode. You going to do it for me? Come on. Good. Okay. So I was really hoping that Chris was going to give that talk, and so I decided to focus on some minutiae because it's a great story. It's a great story. So I start with this photo by Greg Dieselwalk, who's just a really good Florida photographer, and I'm collecting a series of pictures for Enkin's Daily Moon, and this will feature in it. But something which is pretty subtle is, do you see, I've just blown up. He actually caught a meteor in his picture. So how about that for timing? So he's got the launch, he's got the moon, and he's got this meteor. And there's something funny. Let me go back to the original picture. All of the stars, do you see they have that kind of double thing going on? There's some funny atmospheric or photographic thing, but the rocket itself is not doubled. Does anybody have an idea?
That'll be a composite photograph.
Okay.
Maybe have a look at the description, see what he did.
Yeah.
You can get a match on the stars.
Yeah, well, he would have matched the thing that's closer, so anyway, that's not what I want to talk about. We're going to start with the trajectory, which Chris talked about a little bit, and there's this diagram that is kind of the main way that they present it. I'm not going to go through the details that Chris went through, but compare it to the Apollo type of mission where the trip went up to the moon, did a nice close orbit around while they went down and landed on the moon. And when the lunar exploration module got back up to the command module, then they went home. But in here, they had what is called the direct retrograde orbit. Distant retrograde orbit. Yeah, and it's called distant because it actually goes through the L1 and L2 Lagrange points. Okay, and it turns out that given the mass of the Earth and the moon, that's about 60,000 kilometers away from the surface of the moon. And it is a very stable orbit. And if they do the gateway, it is likely where they're going to put that piece, because then there are very few corrections you have to do, because the moon is not actually a point. It is a very complicated body. It's got these things called mascons, where you have the basalt, they're much more dense. And so any object that goes around the moon needs constant tuning of its orbit. But that wouldn't be the case if they go on this distant retrograde orbit. So here's a animation showing what it looks like. So you go boom, you get that little slingshot at the moon, and it takes 6 days to go around, or it would take I think it's 21 days to go all the way around, but then you do a burn, and now it uses the moon again to help it get home. And it has that funny shape there, which I don't think is really helpful. It was when I saw it on a YouTube, what it looks like when the moon is actually moving around the Earth, that you really get a feeling for what's going on. So there you go pretty well straight up to the moon, boom, and then you go, it's around the moon, but actually you're just going to kind of go above and below a bit slower than the moon. And then when it comes inside, it goes up, and then you use the moon and it goes falling straight back to Earth. And I just think that's beautiful.
Yeah, that's something fascinating. Much more different than I had imagined.
And there's another animation where you actually see Artemis not just do that half trip around the moon, but it actually does 1.5 trips around the moon. But because of timing and landing windows and things, it's the timing is really determined by wanting the what was that? It's determined by wanting the spaceship to land in a very particular part of the Pacific so that the ship is there at the right time. And that meant that there are very specific launch windows. It's quite a study to figure out when you can launch something like this. Okay, next, again, Chris talked about these, but these are the CubeSats. I think sometime I'd love to somebody give a talk about what CubeSats are. I know it's a whole thing. It's a geometry of spaceship, of satellite or thing that you use. Like there was the one that went to DART and took a picture of the DART. It kind of separated a week ahead of time, and then it had a camera looking at the collision with the asteroid. Same geometry of ship, of thing, satellite. And so there's on this launch, there's I think, space for 16. There are 10 that were occupied on this launch. And so several, 5 of them were launched about 4 hours after the launch. And then these other 5s were launched away from the spaceship at these different times up to 8 hours later. And they're all sitting here. So right between, see, all of this rocket down below, like 90% of the rocket is just this big fuel tank and a few engines to get it outside of Earth. And then the kind of interesting stuff is all this little stuff at the top. And the transition, which again looks like this, that's a real picture of it, is just using that little empty space between all this firecracker and the important part of the mission. Okay, and you see there's some lunar science, some technology demonstration, some studying radiation. Here they all are. They, you know, some are universities, some are national science agencies, and they're all doing different things. I'm going to focus on this one because I just like the name of it. Omotenashi means hospitality, but it's a backronym. Look at that. Outstanding Moon Exploration Technologies demonstrated by Nano Semi-Hard Impactor. How about that? Anyway, basically, they're going to bounce a little rover on the surface of the moon. It's, I think, 15 kilos, and it's just going to bounce, and it's got some radiation detectors, so it's going to do some science while it's down there. But I think what I like best about it is that backronym. Talking about minutiae. Okay, then the passengers. And again, Chris talked about this. He talked at least about this one. Now, for some reason on our screen here, is there a reason we have to have that thing at the bottom? Is that? Anyway, for the people who are here and the people at home, it's Moonkin Campos is this guy's name. Moonkin is just for cute, but Campos is named after one of the key people who figured out how to get Apollo 13 back home. Do you know anything about that story, Chris?
No, I never heard of the guy until, you know, until they started talking about him in connection with this
This mannequin.
This mannequin. I mean,
Yeah.
there was a whole lot of people who had a lot to do with getting Apollo 13 back. So, but and I'm not sure what his particular role was, but anyway.
Chris is just trying to, there you go. I put stuff on the whole screen and we couldn't see it all. And then there's Helga and Zohar. I showed this slide presentation to my family and they're a bit affronted that the females don't have limbs. How come the guy has arms and legs and the women don't? Anyway, they have, again, each one has its own sensors and things, and the various aspects of the dynamics of the launch. They just want to make sure that the people who go up are going to come back.
Just one comment. One thing I should have mentioned is that a big goal of the Artemis program now is on that first landing, it will land the first woman and the first person of color on the moon. That's an explicit goal of Artemis.
Probably not blue, though.
Never know.
I hope not.
Anyway, then there are Kate, Kyle, Julia, and Sebastian, who are on their way up. I don't know that they actually have a science mission. I think they are PR. I haven't read about any science associated with the Lego people. And then there are Snoopy and Sean. Snoopy is the NASA representative. And I've never heard of Sean the sheep, but apparently Sean I mean, both of these to have been to the moon in their fictional beings. I remember Snoopy being to the moon before Apollo in the 60s, in the cartoon, in the comics. But Sean has a full-length movie about going to the moon, would you believe?
Yeah.
You notice he's wearing a European Space Agency peg, which is, so I think he's very big in the UK and in Europe, but not so much over here.
And those happy people in the background sure think that he's something.
Go online, he's pretty
If you
famous.
haven't seen Sean and Sheep episodes, you really need to. They're
You
very
really
funny.
Okay.
Right, I'm writing it down.
People taking notes. And they apparently are not going to be tethered. They're going to be bouncing around in the command module. Okay, and that's it. I just wanted to have one more spectacular picture that I will feature in Enkin's Daily Moon of this of the launch with the moon in the background. It was a very picturesque launch, and I'm not sure that I am very in favor of. I'm sure this is not environmentally good. There's a lot of hydrocarbons that are getting burnt and set up in the atmosphere, I imagine, but it's very pretty. Anyway, I'm finished.
Oh, wonderful.
Oh no, I'm not. I'm going to show some stuff of my sketches of the moon, but if there are questions, this would be a good time.
Perfect. Was anybody have any questions for Randy?
I
Wonderful.
didn't know there were so many passengers. Thanks for letting me know.
Yeah, wonderful presentation. Thank you, Randy. Why don't you go ahead with your sketches?
So it was a good weekend. My goodness, I was so happy to see the moon. And there's a thing, when it's a waning phase and you see the moon in the night, it means nobody's going to bug me. Like, it's kind of hard to get your telescope out and do stuff when other people want to, talk to you or other silly things like that. So I'm actually really in favor. Most, books about the moon will say, you're probably going to be seeing the first quarter moon because it's there in the evening. But that's for me, it's last is great. Anyway, it was I love the term, a favorable libration. So libration is like Libra, the balance, the moon wobbles, as Jeff was talking about at the beginning. And the Bailey sometimes is actually over the limb. You don't see the whole crater. It's the largest crater on the near side of the moon, but it's not fully on the near side of the moon. And the other thing is, it was a nice, clear sky, and so I could easily see the craterlets, and so I got to draw them. And then, to my great joy, it was out there the next morning. So here are two pictures 24 hours apart, and that's another rare treat to get to draw the same part of the moon 2 days in a row. So Mike, our intrepid photographer, was out on Saturday morning too, and I just wanted to compare. He has a picture of the whole crescent, but I just pulled out the part which is similar to what's in my sketch, because that you see different things. It's as simple as that. The camera sees some things, the eye sees other things, but it is nice to see where they correspond. So I did not see any evidence that Mike was out Sunday morning, but Stephen Arthur Sweet has a post in Facebook called Lunar 101, and he showed this picture from Toronto. So that was probably taken a couple of hours before I did my sketch. And again, you can see here Bailey and its craterlets, but also what's really nice is you can see Gassendi, which is a very flat-bottomed crater, a lava-filled crater and you can see the curvature of the moon. It was even better when I saw it. There was more of the dark, so you just had this rim of white, and it was actually black like the rest of the dark part of the moon inside, and I tried to capture that here. Now I'm really finished. Thank you very much.
Thank you very much. So, yeah, very nice presentation. Thank you. One further bit of trivia. We talked about the origin of the names for Apollo and Artemis. There's actually a darker story to it, and I'll let you in on it. It comes from Greek mythology. Apollo was the god of the sun, and his twin sister Artemis was the god of the moon. Artemis fell in love with a mortal called Orion. Orion was a great hunter, as was Artemis, and Apollo became jealous. So what he did was set up a contest for Artemis to see if she could. He basically said, "You're not that great an archer, but you can't hit that distant black spot." And she, of course, took up the challenge. But the distant black spot was Orion's head. So he tricked her into killing Orion. She was distraught by this because her lover was now dead. So she took Orion and put him up in the sky. So that's how Orion, Artemis, and Apollo are linked.
Thank you, Jeff. I didn't know that story.
No, it's a good story. So Dave Robinson, you had an announcement you wanted to make?
Just very quick. I sing with the Victoria Choral Society along with 3 other members of RASC Victoria, Donna and Ella and Carol Sadu all sing with it. We have a concert coming up on December the 3rd at UVic. We're going, and the other connection is that our conductor, Brian Wismith, is also the director of Vox Humana, who has given concerts up in the Basket Dome several times. So we're going to give a concert on December the 3rd at 7:30 at UVic. We're doing the Maurice Duaflay Requiem.
Lovely.
Also 2 nice pieces by Ubi Caritas, or Sacred Heart, and Luminous Night of the Soul by a composer Oleg Gaio. Very pretty pieces. And then we're going to have some string orchestra who's going to do Serenade for Strings by Edward Elgar and Adagio for Strings by Samuel Barber. So it'll have some very accessible music. The concert's only going to be about 89 minutes long with no intermission, in reference to the fact that some people might be a little uncomfortable with being in a large group for a long time. Tickets are available from UVic, and they're $35 for adults, $10 for students. Keep it in mind.
Thank you, David. Are you able to post that in the chat? Just so
You can just email it to me.
oh, is that how it works? Okay. Thanks very much. Dave Payne, did you want to say something?
Oh, just a quick announcement that the astrophotography SIG is taking place this Wednesday evening. If you're not on the Astrophoto RASC Astrophoto mailing list, send me an email and you'll get an invite to the meeting if you're interested.
Super. Thank you. Reg Dunkley, did you have a few words?
Yeah, regarding the Victoria Center Observatory, due to complications with construction, they're not allowing the public to drive up the hill until construction is finished, and they are anticipating that'll take place around December 22nd. So we're out of business for about 4 weeks.
Okay, thank you. Dave Lee, did you want to have an announcement?
Yes, did you want to, I think Lauri had a question, or she has her hand up anyways.
Lauri, I apologize for missing that. Go ahead.
I was just going to just say to people, but Reg, you've already kind of said that the CU or the DAO is out of commission for the public to all tours and to the Star Party on Saturday night. We've had to cancel the in-person part of that Star Party, and we're pivoting back and going back into our virtual mode again. So all of you are invited to come and listen to Tyrone Woods, who's going to be talking about the Castor, the Canadian Space Telescope. And we're also going to be having some of our lovely photographs again, some of our wonderful people that do that. Thank you to Brock and David and Dave, and we'll invite some of our UVic students to come back for the Ask an Astronomer portion. And we would love to have your support to come and be on that. It is on our YouTube, but we can also get you a Zoom link if you prefer to be on Zoom link rather than on the YouTube. There's still quite a lot of problem with the road. If you have been up lately, it's completely sheared away on the one side down the mountain, like on the mountain side. And they are having to completely reconstruct that. And what happened is last week when we had some people come up, some students come up with buses, is that the big construction vehicles did not obey the red and green light signals, and the buses had to be asked to go back up the hill, reverse back up the hill with kids inside, and no barriers and no flaggers, nothing at all. And it was a huge problem. And we connected with the DAO people right away, and within about I would say maybe 2.5 hours or so, the road was closed and some of the contractors were fired. So it was a really big deal. And right now, there are now flaggers. There's a flagger up on the hill that is looking after the side. So there's now actually a person looking after as well as the lights. And when I had to give a presentation up on the hill, a virtual presentation today for another group of students, and they did allow me to go up the hill, and Derek Mann even said that somebody went bombing through the red light and passed the flagger today without stopping. Like, so unbelievable amounts of things. Derek was just beside himself, thinking, what do we need to do in order to keep people safe on that road? So
AR-15s. Close it.
Sorry?
Close it.
Close it, yeah.
Well, I mean, they're letting the staff up, but I'm not, anyway, all the public is closed, so you cannot walk. Even Elizabeth Griffin, if any of you know Elizabeth Griffin, who works up on the hill, who's 90 or something, and walks up the hill and walks back down the hill, has been told that she can't walk up the hill because she would not be able to make it between the red light, the green lights. She would not be able to go from one to another and get there in time for there to be somebody that won't come back down the hill. So it's there's lots of good stuff happening. Anyway, we would love your support. I mean, again, the FDAO has had to kind of just pivot again and close things down, and it's like we can't catch a break. So we'll see whether or not we can kind of continue all this anyway. We're going to go into the schools if we can, if the teachers would like us to. We are going to go into the schools and see whether or not we can help out that way for some of them at this point. Okay, that's all I wanted to say. So maybe we'll see you on Saturday, 7 o'clock, 7 to 9 on Saturday. Thank you.
Wow.
Okay, thanks, Lauri. I think I saw Dave's hand go up, David Payne. If not, I'll proceed.
Dave's hand went up and went down. Dave, did you have a question? Or
Yeah,
was
it was just referring to Lauri already said whether she needed help with the photos on Saturday.
Yeah, I'm going to be contacting everybody, Dave. We're going to do our usual stick that we did on virtual star parties.
Yeah.
Okay. Okay, so let me just get my stuff together here. Yeah, so there's a SIG this Thursday for the Makers Group. If anybody doesn't know what the Makers Group is, it's for the people that are in our astronomy community that like to be handy, maybe likes to use a bit of duct tape and stuff. But maybe more than that, we like to repair things and we like to maybe even invent or construct things. So if you're interested in that kind of thing, join us on Thursday. If you're not part of the group, let me know. I'll make sure that you get onto the distribution list. I don't know if we have anything planned for this Thursday, except I'm just going to share what I've been doing with my microprocessors. I've been kind of working on a couple of environmental devices, and I can show you how far I've got so far. So that's a Makers Group. And then here's a hypothetical group. So I've been toying with the idea of constructing a citizen science SIG. Now, I don't know if this will replace something or just be another SIG. So I'm going to leave you with some information, and then later on when there's a little bit more time at a cafe, I'll give you a little bit more detail. Now, you've already been exposed to citizen science in a sense with our sky brightness survey that we did in September that kind of classifies as citizen science. So I actually like this description from National Geographic. They say around the world, ordinary people of all ages engage in citizen science. And it's this participation in projects that allow volunteers and scientists to work together to answer real world questions. Now, interestingly enough, citizen science is not anything new. Variable star observation at the turn of the last century became very popular, and it was the synthesis between scientists and volunteers, interested parties, and the public. There were a lot of research into the study of stars, which under a time domain yield very interesting results, because nothing actually really is static up in the sky. So stars are constantly going under transformation. And amateurs of all sorts, myself, and I know Michelle, that used to be with our center, is a variable star observer as well, monitor and actually contribute to a public database of the observations. So I'm going to sort of paste these URLs into the chat. And if you have any questions now, I can maybe try to answer them. Or if you have any interest, let me know by email. So I'm just going to stop the share. And I'm going to see if I can paste in these URLs for you.
Two other common citizen science things are meteor counts and occultation timing.
Yes, there's many instances of this. Mainly, I mean, people can do this and not report either. I mean, there's that kind of citizen engagement, but most of these things are designed to contribute to a large a database, a public database of some sort. That's certainly what the AAVSO does. But yeah, I okay. Lauri just put in Galaxy Zoo. Yeah, there's actually a lot of things which are not requiring any equipment. Galaxy Zoo is one of those things where you're presented with images and you're trying to find galaxies. I mean, there are kind of programs nowadays that use machine learning to sort of detect things, but the human eye is still pretty hard to beat. So human observation is important as well. So I don't know if there's any questions. If not, just send me a note if you're interested in starting a group. And I will always alert you to things that I'm working on. But if you want to work on something kind of long-term or have questions, I can certainly form another group.
Wonderful. Thank you very much, Dave.
You're welcome.
So anybody who's interested, please get in touch with David. Dave, we'll look for that presentation in more length at a future Astro Cafe.
Yep.
Are there any further questions or any further presentations, announcements that anybody wants to make? Okay, well, thank you. It's been.
No, I think Reg has a question.
Oh, okay. Good.
Thank you. This is actually for Peter Jedicke. On early Saturday morning, there was a meteor that flew across southern Ontario and apparently might have even hit the ground near Grimsby or something. Peter, did you see anything about that? Or
Yes, I did. How much would you like to hear?
I'm quite interested.
All right, well, okay, so I actually got a phone call from a friend in California who works at Jet Propulsion Lab and was doing the calculations and couldn't find any of the research scientists to call. So he called me because he knows me. And so my wife and I hit the car and headed east of London to try and see this thing. It was predicted for 3:26 in the morning on Saturday morning. And we had mostly overcast skies through southwestern Ontario, but it did kind of look like, strangely enough, pretty much the zone where the prediction was located seemed to have a little lighter clouds. So I definitely thought it was worth going. What made this one special, for those of you who either didn't hear about it or you're just not quite connecting the dots yet, when we see meteors, doesn't matter how bright they are, bolides, wonderful things, they're very rarely predicted ahead of time. You're out there, you see a meteor, oh, wonderful, there's a meteor. But thanks to modern technology and all these survey programs, there have now been, I think, 5 or 6 previous incidents where an asteroid was discovered in space. The orbit was calculated, and it was calculated to be on an impact trajectory with the Earth. And so this is either the 6th or 7th example of that. And this fellow, that friend of ours from in California, he looked, and the first calculation that said it was going to hit the Earth said it's going to hit the Earth near London, Ontario. And he thought, oh, he knows people in London, Ontario. And turns out I wasn't the only one that got informed. I found out a little bit later that there's, a mailing list for folks interested in meteor studies. And at 1:20 in the morning, there was a post put onto this meteor list saying that this object had been discovered, and preliminary calculations showed it was going to hit the ground somewhere near Brantford, Ontario, which is about, 100, maybe not quite 100 kilometers east of London. And every subsequent calculation that was done moved the impact area a little further east. But I didn't really kind of realize all that. I heard the change from London to Brantford, basically. And then I also heard that they were saying it was more like Niagara Falls as we were driving out of town. But I was actually just as much interested in getting out from under the clouds and the city lights as I was in, getting closer to the impact side. I wasn't worried about that. Turns out Dave Clark also heard about it right at 1:20 and jumped in his car and drove out. He made it almost to Brantford, and they had more or less clear skies there. There were also at least 2 people in London who I know of who stood out basically in their backyards. One guy had a photograph. Would you like to see it?
Yes.
You show it.
Okay, give me a second to make sure I have the right photo here, because I got a bunch of new photos and I wouldn't want to bore you with the wrong one. Okay, it's not there. Hang on. I know I've got it. Just give me a second. I'll find it on my hard drive.
Reg, did you know that Peter was involved?
No, I knew he was back in Ontario, and I thought that he was the sort of guy who might be involved. So this is great news for me. That's lucky.
Anything coming up?
That's pretty good.
Is that coming up on your screens, folks?
Yeah.
Yeah.
Great.
So I don't actually know where this person lives in London, but he works for the Pan-STARRS survey telescope system, which is located in Hawaii, as many of you will know. And he lived there for many years. And during COVID, he came back to London, and they just kept him on staff. So now he does all his work remotely. And so basically, there he is at 1 o'clock in the morning, and he had someone from Hawaii call him and say, check your computer right away. And he's able to check the discovery photos and all that. And he was basically able to see that the calculation was showing. And so he basically stepped out into this, what I assume looks like a soccer field, which must be close to his house. You can see the moon, folks, in the bottom right of the picture, just above the trees there. And so obviously you can see the straight line. And he, if I have it right, this is a 15-second exposure. So it took that at least that long for the thing to get across the sky. I have another one. Give me a second. Let's see, where's the other one? And then there's a bunch of movies here. Actually, let me show you the one of the space photos first, because this was while the object was still in space. And can you see that, or is that, did I not make it small enough?
That's good.
How's that look?
Good.
So this was taken at Lowell Observatory. I don't have the exact time it was taken, but believe it or not, they're actually able to use the discovery just not much more than an hour or two before this picture was taken. The discovery photos, calculations are made of the orbit right away, and they're able to use those calculations to track this photo on the moving object so that the star images are trailed. So the object that's standing still in the middle, that's the object. The estimation was that the object's about 1 meter in diameter. And, you know, meter in diameter objects make very nice bolides when they come into the atmosphere. And the idea of actually knowing that one's coming and being able to tell people about it, well, that was kind of special. Now, I'm not sure about the movies. Which movie do I have? Do I have?
Well, the other thing is we are kind of over our time for the room.
Oh, yeah. Okay. Well, that's why I asked you if you really wanted me to talk about this. I'll cut to the chase. I didn't see a thing. I have no idea why. I was literally standing right basically under the path of the meteor. I was looking up. It was bloody cold, okay, and I don't like cold anymore. So, but I was kind of excited because I thought this would really be something neat. And anyway, so the time came and went. You know, I waited 3 or 4 minutes, and I thought, I don't know what's going on. I haven't seen it. And right away, I was getting messages, even though we were, you know, on the roadside outside of London. I was getting messages on my phone telling me that, in fact, yeah, other folks had seen it. So I just don't have an explanation for why I didn't see it. I hope I'm not that blind.
Well, thanks so much for that, Peter. I shot from the dark. I put you on the spot, and you have the right stuff. Well done.
Well, thanks for asking, Reg, because as many of you have figured out already, I'm quite a ham and I love to talk about these things. And this was a really, really neat opportunity. If I'd seen it, I think I'd be really feeling over the moon about it. Dave Clark, who saw it, you know, he's studying this stuff for his PhD. His PhD is about predicting small objects that are gonna, you know, impact. And he never figured in his life he'd have a chance to do this, because the predictions never come in more than a couple hours in advance. And they're usually somewhere else in the world, Botswana or, you know, the Beaufort Sea or something. And here we are in Brantford, Ontario, all of a sudden Zoom drive, of course. So he's just pickled by this whole thing. It's just marvelous. I haven't heard any reports of meteorites falling. So I've got more pictures. If you want, I'll talk about it next week or something. Actually, I'm going to be on the road next week, so I don't know if I'll be able to join in, but I'll talk about it sometime if you want.
Great, thank you.
We'll capture that sometime. So thanks, everybody, for attending tonight. It's been really interesting meeting. So I'll declare the meeting closed.
Sure. Thanks,
Bye,
Jeff.
everybody.
Bye, everybody. Thank you.
Well.